Hi everybody. Now we continue with 8th week. I think you can see my screen. Let's check it again. Yeah. Now we have some identities from last subject. So we will continue with derivatives. I mean differentiations also. Now cosine square alpha plus sine square alpha is equal to 1. This is the first identity for us. And next one, 1 plus tangent square alpha is equal to secant square alpha. This is second identity for us. And 1 plus cotangent square alpha is equal to cosecant square alpha. And this is the third identity. And the other one, such as different from this, cosine A plus B is equal to cosine A cosine B minus sine A sine B. Let's say this is the fourth one. And sine A plus B is equal to sine A cosine B plus cosine A sine B. And this is the fifth one. And now let's show these three of them identities. So we may continue with raising these. We can use a triangle. So let's show 1, 2, and 3, I said. So we have a triangle, you know, a right triangle like that. And we have A here and B here. Let's say our angle is alpha here and C here. You know that A square plus B square is equal to C square. And here cosine alpha is equal to, here is adjacent over hypotenuse, and sine alpha is equal to opposite over hypotenuse. And finally, we know that first equation says that cosine square alpha plus sine square alpha. So it is b square over c square plus a square over c square. So finally, we have b square, a square, and c square here. So also from this equation, right angle equation, we have c square here. So it's equal to, it equals 1. Yeah. And second one, also we can use the same thing, and there is here only. So for the second identity, we have 1 plus, tangent is equal to sine over cosine. So this is square, and it's equal to, when we equal the identities here, so cosine square alpha plus sine square alpha over cosine square alpha. Here is equal to 1 from first identity. So 1 over cosine square alpha. And we also know that 1 over cosine alpha square is equals to also this one. And this one is equal to secant alpha square, that is secant square alpha. is the end of the proof of the identity 2. And finally, third identity. For the third identity, what can we do? Let's look for this one. And now we know that also 1 plus cotangent square alpha is equal to 1 plus cosine square. We know that cosine over sine is equal to cotangent. So cotangent square, cosine square over sine square alpha. And we also again equal the denominator. So this is sine square alpha plus cosine square alpha again, and sine square alpha. This is the same of the proof of the second identity also. And upper side is 1 and denominator is sine square alpha, and we can write same things again. Sine alpha, I take this square here, so it equals, we know that here is equal to cosecant alpha, and finally this is cosecant square alpha. This is the end of the proof of the third identity also. Now, for the fourth and the fifth equations, we only use these equations and we don't use the any proof here. But you have to know first three of the identities and the proof of these. Maybe for the homeworks and anything other. Now we have half angle formulas. So let's write this half angle formulas. These are for the final exam also. Final exam consists of these new subjects. What I mean, before first 5 identities, first 3 and 2 formula, and now half angle formulas. Cosine squared, let's say theta, is equal to 1 plus cosine 2 theta over 2, and sine square theta is equal to 1 minus cosine 2 theta over 2. And we have also the law of cosines, that is, we have a triangle like that, and we have an angle again alpha here, and A here, B, and C here. And finally, we have the law of cosine formula like that. C square is equal to A square plus B square minus 2AB cosine alpha. Yeah, this is the law of cosine. So let's do an example for that. Again, let's draw our triangle. Yeah, our angle is 120 and 2, 5, and we don't know C here. A, B, and C are points. So question is find C. What is C? So from the formula here, we can do that. C square is equal to A square plus B square minus 2AB cosine alpha. So A square is equal to, here we have A here and B here. So 5 square, 2 square minus 252 cosine 120. you know, 120 for the cosine 120, we have minus cosine 60. Where do you remember this one? You know, second quadrant, we have only sine positive, all sinus, and the other one, tangent, cotangent, we know, and cosine here. So cosine is negative, so we have minus cosine this one, and this one is equal to minus 1 over 2. You can remember it from yellow table. You can remember the yellow table from the videos also. And finally, 25, 4, and 20 minus 1 over 2. We have here positive, so it's 10, 29, and a 10, 39. 39, this one, c square is equal to 39, so c is equal to 39 in square root 2. Square root. Okay. And now I have no subject from these things, so we can continue with differentiation. Now let's write for differentiation again. Okay, you can also do you can use the half angle formulas, and maybe we can do some examples also in the online lecture. Okay. Now differentiation. Yeah, this is new subject. Let's give a definition for that. Definition for derivative functions also. This is derivative function. The derivative of a function, fx, with respect to the variable x is the function f prime. We use this, and we can read this one prime, and f prime, whose value at x is, we can write the formula like that: f prime x is equal to limit h goes to 0 and f x plus h minus fx over h. And also we can use like that: f prime x is equal to limit z goes to x, fz minus fx over z minus x. We can use either this one or this one, second one. These are the formulas for differentiation and derivative of the function. So if, of course, provided the limit exists. So now we have a note. Yes, I have a note for this one. We have two of them here. I said two of them here. We can use these. And now note is the process of calculating a derivative is called differentiation. And now So we use the notation f prime or d over dx fx, and I have also some more notation, and I will give it in this lecture in the future time. Now let's find some examples, the solution of some examples. So the example is, question is, differentiate fx is equal to x over x minus 1. So solution is like that. We know that f prime x is equal to limit h goes to 0, and fx plus h minus fx and over h. We try to do this one by using this function. So put x plus h first in the fx function. So x plus h over x plus h minus 1 and minus fx, you know, x over x minus 1. And this one, let's put it in the right place here. And now here we have h, and we have also limit h goes to 0 here. And let's use here. Yeah. Now, again, write it again here. And now we know that this A over B minus C over D is equal to AD minus CB over BD, you know. So we can write that x plus h x minus 1 minus x multiplied with x plus h minus 1 over x plus h minus 1 and x minus 1 and multiplied with h, of course. So finally, let's find these multiplications. What are they? X squared minus x plus hx minus h and minus x squared minus xh plus x over, of course, we have here limits h goes to 0 here, and we can write the same things on the denominator again, x minus 1 multiplied with h, and finally limit h goes to 0, and we have you see x squared minus x squared and hx plus and minus hx, and we have here minus x and plus x here, so we have only minus h here, and we have x plus h minus 1, x minus 1h. So finally limit h goes to 0, and we have you see minus h here and h here, so we have only minus 1 here, and x plus h minus 1, x minus 1. So finally, for finding the limit, we have to put h to 0. So if we put h to 0 here, minus 1 over x minus 1, x minus 1. So the result is minus 1 over x minus 1 squared. So we find that f squared, f prime x, that is differentiation of this one, is minus 1 over x minus 1 squared. This is the solution of the question. So next one, Next one, we have another example. And I will also use, of course, black. You want black one. But for the cancellations, I use different colors so it can be understood easily. Now, next one, we have this example. Find, let's say A, find the derivative. Find the derivative of y is equal to square root x for x is bigger than 0 or x is positive. And second question for this example, find the tangent line. Find the tangent line to the curve. Which curve? This curve. Y is equal to square root x at x is equal to 4. So for the solution of this question, we use the other definition for the differentiation. Which one of that? This one. Limit z goes to x. We have fz minus fx over z minus x. So if we use this one, write again this one, z goes to x, and for fz, if you put z here, we have square root z minus square root x over z minus x. Also, we can rewrite this one, z minus x, as like that. How can we write? We can write it like that, square root z minus square root x square root z plus square root x. How can we write this one? We can write this one like that. You know that this one is equal to a minus b plus a plus b. So we use this one here. So finally, this one is okay. And limit z goes to x. And again, let's use this one. This one goes, and this one goes. You can see. Finally, we have 1 over square root z plus square root x. And if you put z for x, or x for z, and 1 over square root x plus square root x, it is 2 square root x. The solution is this one. But the second question at B part, it says find the tangent line to the curve, this one, y is equal to square root x, at x is equal to 4. For this one, for finding the line, finding for a line, we have to find, first of all, the slope of the line. So slope is equal to finding or putting the x is equal to 4 to the differentiation function. So f prime x here, we have to put 4 here. So 1 over 2 square root 4, and it equals 1 over 4. This is the slope. Slope for the tangent line. Now we have a slope, and you know that for a line, for writing a line equation, we have to know also a point. For the point, we put this x, fx, under fx. So it is f4 is equal to square root 4, and it is 2. So our point is 4, and ordinate is, abscissa is 4, and ordinate is 2, and we have slope 1 over 4. And finally, we can write that y minus 2 is equal to 1 over 4 x minus 4, the abscess here and ordinate here. And finally, the line, the tangent line is this one. And you can also write 4 multiplied by 4 here. 4y minus 8 is equal to x minus 4. And finally, 4y minus x is equal to 4, or maybe 4y minus x is minus 4 is equal to 0. These are all the answer of this question. Yeah. Next one. I said that in the following time I write the notations. So now I'm going to write some notation here. Notations. F prime x is equal to y prime. I'm going to say again, this one means prime, y prime, dy over dx, or df over dx is equal to d over dx, fx. And now I want to talk about this one, dy over dx. It is derivative of y with respect to x. It's a derivative of y with respect to x. And if we have like that, f prime a is equal to dy over dx, derivative of y with respect to x, and x is equal to a. This is at x is equal to a. So df over dx, or df over dx at x is equal to a again. Now let's use the previous example for this one. Which one is our previous example? It is fx is equal to square root x, and we try to find f prime x. So we know that it is 1 over 2 square root x. So if we want to write this one, f prime 4 is equal to d over dx at the point, of course our function is this one, at the point 4, and finally 1 over 2 square root x at the point 4. And if you put this 4 on the function here, derivative of the fx, so 1 over 2 square root 4 is the answer of the question here. And it's also the slope of the line. And finally, we can write a graphing derivative. Also, we can stop here, I think. And don't forget that we are at the graphing of the derivatives. So let's write it and don't do anything. Graphing derivative. Okay. We will continue at the 9th week. Okay, see you. Bye-bye.